Hi, I'm Chris, and today I want to show you the Rawx Series bundle. The Rawx Series bundle from Rawx consists of Rawx, a polyphonic signal manipulator, Rawx Focused, a more streamlined version of Rawx that omits some of the inputs and outputs for a more streamlined interface, the Rawx MTP, the mono to poly tool, the Rawx PTM, poly to mono tool, the Rawx PTMTP, poly to mono to poly tool, and the Rawx Twister. Starting off with Rawx MTP and PTM. First, we need these tools because these two are the most helpful tools when dealing with polyphonic and monophonic signals in voltage modular. The mono to poly, as the name suggests, takes monophonic signals, so single signals, with these single inputs, and forward them to this polyphonic output. Each poly channel has its dedicated attenuator, and the overall output also has an attenuator. One last feature, we have the trademark Rawx config menu, which lets us change the poly range from 1 to 8 voices to 9 to 16 voices. Please note that 9 to 16 voices only makes sense if you have more than 8 voices selected for the polyphonic configuration in voltage modular anyway. PTM, basically the same but the other way around. You feed in a polyphonic signal and this polyphonic input here with its own dedicated attenuator, which then gets split up into its individual channels for these monophonic outputs. Again, each output has its own dedicated attenuator. So what can you do with this? Now let's use Rawx and connect the individual channels to this neat little voltmeter we got here, so we can see what's going on in the signal. Rawx is a tool that lets you manipulate polyphonic signals, or the channels, the individual channels of a polyphonic signal, in a very intuitive and creative interface. Namely, this canvas which lets you draw freely to set attenuation, inversion values for the individual channel voltages and a DC offset for each channel. With no input connected, Rawx is a straightforward DC source with 8 channels of DC values, and we can either use the polyphonic output or we can use the individual channel outputs, which output volumes per channel. What's special about this canvas is that it employs some very nifty features. For starters, you can freely draw and the output adjusts accordingly directly. If you hold the Shift key while dragging over the canvas, you set one exact value for each of the bars. So if I want this value in particular, I hold the Shift key down and then I move over the bars. Or let's say I want this for these, here Shift, there Shift, and I can set precise values. If I want to create gradients or slopes, I can hold the Alt key on Windows, and it's the modifier key on Mac, and I can drag over the canvas to generate these lines. Works the other way around too, of course. Alright, I have a nifty reset button that only resets the canvases. I have a randomize button that gives me random settings for each bar. Great if you just need some quick inspiration and connect this to some effect, and now you can randomize what the effect does. You can lock the bars with these lock switches. We can lock the attenuators, and now if I drag over the bar, only the DC offsets are manipulated, but the attenuators stay the same. This applies also to randomization and reset. I can do the same for the DC. Now only the attenuators are being manipulated because the DC is locked. If I lock both, well, I can do nothing because now everything is locked. No randomization, no reset. Please be aware that the right-click module reset controls still works because this also resets the locks. The default range for the DC is -5 to +5 volts, and the default range for the attenuation is also +5 to -5. So let's say can interconnect this, reset this DC. Here we have the DC output of the second channel that's fed into the first channel of Rawx here, and with this attenuator I can set attenuation from full to inversion to muting. Now if I want more fine-grained control over the DC bias and the attenuation, I can use these multipliers here at the top. By decreasing the multiplier, I now have limited the range, but I have more fine-grained control. Let's lock DC right here, but I have more fine-grained control over what's going on. Same applies for DC. If I go the other way, it goes up all the way to 9.99. Let's reset the attenuator and make it full. I can get up to 94.95 volts from one single DC output. And of course I can overdo it completely by also upping the attenuator multiplier and then feeding one channel output into the next channel input, and I can get very high voltages out of this. It's great for doing stupid stuff like overdriving filters or really crushing a signal into an overdrive effect or distortion effect. We have two modes in total for the canvas. Let's randomize to see the effect. We have the bipolar mode, which is active by default, and we have a unipolar mode. With the unipolar mode, I only have positive values for the DC and the attenuator, which turns the attenuator into an attenuator. This gives you more control because now the full range, the full width of the canvas is dedicated to the positive range. You can still get negative values by using a negative multiplier. Here's a quick power user tip. If you hold Shift and click on the multiplier, it inverts the multiplier settings. So you can quickly go from +1 to a -1, or whatever value you set to its negative value. Another neat feature of Rawx is that you can manipulate all of the bars at once, or not at once, but all of the bars by moving over the canvas. If you need more fine-grained control, you can right-click and edit a value to a precise value, but one limitation of the system is you cannot use performance knobs or automation on these values. And also you can't map a control to this value. However, there is a second mode in Rawx. Let's call this mode the wiggle mode, and now we have line mode. In line mode, the canvas is deactivated and you can only move one switch at a time, one bar at a time. So no matter where I am, if I click on DC4, I am only ever able to manipulate DC4. You can still edit values, and now you can, I have already assigned this, you can use automation and performance assignments and remote controls. So let's assign this to knob 2, just to show this. If I switch back to wiggle mode, performance assignments and automation are deactivated again. We have at the top the main attenuator and main DC offset, which add an overall a global DC and an overall attenuation to all channels at once. This is great if you, for instance, set a particular pattern. Let's say I want to control a filter and I want to have different offsets and different strength of the filter modulation. Now I can control the overall filter with this main canvas at the top. And of course, Rawx is a over-the-top poly to mono and mono to poly converter with attenuators and DC offsets in between as well. So I can, let's not use a second Rawx module. Let's get Rawx focus, just a few quick connections, and let's say I want to have, or let's make it one value here and one value there and one value here and another here. And now I have, let's reset so it becomes more obvious. Of course, I need to adjust the attenuator values so that the input is not attenuated and routed to the outputs. And as you can see, each channel now holds the values of the polyphonic input. So each mono output has the value that is present in the polyphonic channel, and the polyphonic output also has these values. So poly to mono, and the same applies. Now we need a second Rawx module, Rawx. If I have a mono signal, I have to unlock DC, and I can convert this mono signal, these three channels, to the polyphonic signal, and the monophonic outputs still have the monophonic inputs. Alright, so that's Rawx. Very versatile module to manipulate polyphonic signals. Rawx focus is the same without the individual outputs and with a more squished UI. It does not have a randomize button, but if you hold shift and click reset, you can randomize as well. That's a neat little power user trick for you. It behaves the same as Rawx, so it also has bipolar, unipolar mode, has wiggle mode and line mode. You can lock, wiggle mode, you can lock either attenuators or DC bars, and you have this main display and also the multipliers that also invert when you click them and hold shift. And as always, double click to reset also works on each bar, of course. Alright, let's say you only want the poly to mono or the mono to poly feature, then these little tools come into play. The Rawx poly to mono and Rawx mono to poly. You can feed a polyphonic signal in here, into the polyphonic input, and attenuate each channel with the small attenuator knobs. And the same, of course, is true for mono to poly. Okay, first three channels. Rawx provides the monophonic output, so 8 monophonic outputs. We only use the top 3 that are turned into a polyphonic signal by mono to poly, and then turned into monophonic outputs again by poly to mono. So if we set the poly range to 1 to 8 again in mono to poly, and also have the same range in poly to mono, we can then use this Rawx instance as a DC source, convert the mono outputs to a polyphonic signal with mono to poly, Rawx MTP, convert this polyphonic signal to monophonic signals with the Rawx PTM, poly to mono, and have these values come out at the end again. Let's compact it so the signal flow is more obvious here. And each channel now has individual attenuators and the main attenuator, of course. Let's start over with the PTMTP, poly to mono to poly. There are times when you have a polyphonic signal and you want to have a mono signal from that polyphonic signal, but you do not want an individual channel, you want all channels summed into one. And that is exactly what this tool does. We have 8 channels of DC offset. Each of the 8 Rawx channels provides 5 volts of DC into all polyphonic channels, and these polyphonic channels are now summed into one monophonic signal by the poly to mono to poly tool. You get a polyphonic amplifier so that you can amplify, attenuate, or even attenuate individual channels before they are summed. And you also get a mono amplifier that attenuates the summed signal. So the upper section is concentrated on the polyphonic signal, then it gets turned into a monophonic signal, and this section deals with the monophonic signal. You have a little switch that you can use. Let's remove the attenuation, the switch that you can use to average the signal. So with the switch in the lower position, every poly channel is summed into one big sum. So 8 channels of 5 volts equals 40 volts. Or you can use the average of each channel. So now we have 8 channels of 5 volts, which is 40 volts, divided by 8 channels again, which gives us the 5 volts at the output. Okay, the MTP section works exactly the same, but the other way around. Now we have a monophonic input, and this monophonic input is replicated on all poly channels. So let's use our trusty PTM tool again. We have this DC source, courtesy of Rawx, that feeds the monophonic input of the MTP section of PTMTP. That is then replicated to each poly channel. So you can feed one monophonic signal. Let's say you want to use one oscillator, one monophonic oscillator that should be distributed to 8 different filters. Then you can use this MTP section replicating the monophonic oscillator to 8 poly channels. And each channel exactly has the same value. Again, there's a little switch that lets you use the average of these channels. So we have 5 volts input voltage here at this monophonic check. We have 8 channels of poly voices, and with the switch in the lower position, each polyphonic channel gets the full 5 volts, and with the position in the upper, with the switch in the upper position, each channel gets the input voltage divided by the number of poly channels. Again, we have a monophonic amplifier with a dedicated attenuator switch, and we have a polyphonic amplifier that lets you amplify each channel of the polyphonic signal that is produced from the monophonic input individually. Now there's one last twist that PTMTP provides. In the config menu you can set a polyphonic offset and a polyphonic range. By that you can say PTMTP to start at polyphonic channel number 2. And now, as you can see, the first 2 channels of the polyphonic signal produced by PTMTP are zeroed. And the first channel is now the 3rd channel. So we've offset the polyphonic signals by 2. We can also limit the polyphonic range. Let's say I only want 3 channels. So now you can see the 4th value is nulled because we only have 3 channels that are offset by 2. Again, if I set the offset to 0, we have only the first 3 values. And we can reset that, of course. The last in the series, the Rawx twister. Now this model is a little different to what we have seen so far, as it is not concerned with being a utility module that has creative roots, but it is a fully creative tool. It takes a polyphonic signal, applies some modulation, and outputs a polyphonic signal. No mono to poly magic here. So let's take our polyphonic signal from Rawx. Let's clean up a little. Again, use our PTM tool to convert the polyphonic signal into monophonic signals, so we can watch what happens to the signals on this voltmeter. And also I will use this oscilloscope to visualize what's happening to the channels. Let me set up real quick. Okay, no trigger here. So now we have 5 volts on each channel. Let me draw a quick line. To demonstrate what shift does, we need different values because it's more obvious to see what it does. It shifts the polyphonic channels. So currently the first channel carries a signal of 4.04 volts, and if I shift by 1, it is now on the second channel, and the 8th channel is rolled over to the first channel. See, now the 8th channel has minus 3.48 volts and the first channel has minus 4.76 volts. If I shift once more, now the first channel has the value of the recent last channel and the second channel has the value of the first channel. And in the scope you can also see that happening. Of course there is a CV input. Let's just real quick use this channel with a dedicated attenuator that you can use to control the shifting. Okay, there's tilt, which lets you tilt the values. For this it is easier to have a 5 volts on each channel. Now if I reset tilt, we have 5 volt on each channel, and if I increase tilt, to the positive side, it will tilt towards the lower channel. Now the constant 5 volt signal on each channel is tilted so that the last channel has 0 volts and the topmost channel, or the first channel, has 10 volts. I can reverse that by tilting in the other direction. Now let's turn the scale down so we can see what's going on in the oscilloscope. So the signals spread from the middle or approach the middle. And in the other direction, of course, it's the other way around. I can shape this tilting logarithmically or exponentially to further influence what the shaping does. And of course, it can be controlled via CV. Rawx Twister does not have a config menu because it is not concerned about the polyphonic channels. It just uses every channel that is available. So if you set to 8 voices, 8 polyphonic channels globally, then it will use 8 channels and it will expect 8 channels here. And if you set it to a lower, let's say 4 values, then the tilt will adapt to that and work on these 4 channels. And also the shift, of course. So no user intervention needed. It will automatically adapt to your global voltage modular polyphonic settings. That was a very long and technical description of the Rawx series. I hope you found it useful to see what these modules can do and what they are capable of. Hope you enjoyed. As always, if you want to see more of this, please like and subscribe.